Today, we are diving into a really cool case study. It's about how a massive distribution center, run by a Fortune 50 company, finally cracked the code on its single biggest production headache. And the solution they found? Well, it gives us a pretty fascinating peek into the next generation of industrial safety tech.
So get this, here's the central irony of the whole story. The company's biggest problem, the thing that was slowing them down the most, wasn't a broken machine. Nope, it was the very safety system they installed to prevent accidents. It's a classic case of the cure being almost worse than the disease.
And look, we're not talking about some minor inconvenience here. For a facility that is shipping thousands and thousands of pallets, every single unplanned stop, what they call a nuisance stop, it all adds up. We're talking serious losses in time, in money, and in overall efficiency. It was $1 million glitch.
I mean, just let that sink in for a second. The number one reason for production grinding to a halt wasn't a mechanical failure or some software bug. It was a false alarm from the safety system. And it was happening every single day. This meant operators constantly had to stop what they were doing, walk over to the line, and manually reset everything just to get it moving again. What a headache.
You know, what's really wild is just how ordinary the causes were. This wasn't some complex, high-tech failure. It was just the messy, day-to-day reality of a busy warehouse. Things like a flimsy little tail of stretch wrap hanging off a pallet, or a barcode label that's just starting to peel up at the corner, or even just the constant vibration from all the machinery causing a sensor to shift by a tiny, tiny millimeter. These were the culprits, shutting down the entire line.
So that begs the question, right? Why was the system so incredibly fragile? Well, to get that, we need to take a quick look at the traditional safety technology they were using. It's a system that's super common across the industry, and its core weakness is really at the heart of this entire story.
Okay, so on the left, you've got the theory. And it sounds simple enough, right? A couple of external sensors see a pallet coming, and they basically tell the safety light curtain, hey, stand down for a sec, this is just cargo, not a person, let it through. But then, over on the right, you see the messy reality. Those same sensors just aren't smart enough for the real world. They see a stray piece of plastic and they panic, shutting everything down. They were basically designed for a perfect lab environment, not a busy production floor.
And this, of course, brings us to the solution. This is where things get really interesting, because it represents a totally different way of thinking about the problem. The system integrator on the project, a company called Hantech, brought in this really innovative technology from Leuze.
And right there, that's the absolute game changer. The entire problem was being caused by those external muting sensors. So what did the solution do? It got rid of them completely. No external sensors means there are no sensors to get fooled by stretch wrap and no sensors to get knocked out of alignment by vibration. It attacks the problem at its absolute root cause.
So you're probably asking, how in the world can you have safety muting without sensors? Well, the answer is in a much smarter, much more robust system that relies on two separate signals that have to happen at the same time.
This is the magic of smart process gating, or SPG. Think of it like two-factor authentication for your safety system. It needs two things to happen simultaneously. First, the main brain of the factory, the PLC, has to send a signal that says, okay, I've scheduled a pallet to move through this exact spot right now. And second, the light curtain itself has to be physically blocked by that pallet. Only when both of those things happen together does the system mute. A stray piece of plastic can't fool it because the PLC never gave the okay in the first place. It's brilliant.
And then there's another really clever layer of intelligence called reduced resolution, or RR. This is what makes the system so perfect for the real world. It essentially teaches the light curtain to ignore small, flimsy things like those film tails and loose labels we talked about. But it's still perfectly sensitive enough to instantly detect a solid object, like a person's hand. It just filters out all the background noise.
So we have the problem, and we have this really elegant solution. But did it actually work? Let's take a look at the data, because the results here were about as black and white as you can get. I mean, this table really says it all, doesn't it? Nuisance stops went from being a frequent, daily frustration to completely eliminated, gone. Unplanned downtime dropped to almost nothing. Operators no longer had to constantly babysit the system and reset it. And just look at that last row. System availability, the uptime, became rock solid.
Let's just pause on that number for a second. Over 99.5% availability. For a system that used to be the #1 cause of faults in the entire facility, that kind of turnaround is just incredible. It represents a huge, huge gain in reliability and, of course, in throughput.
And hey, you don't have to take my word for it. Here's a quote that comes directly from the facility itself. They said the change was so dramatic, so profound, that they immediately decided to make this new tech the standard for all their future expansions.
That's about as powerful an endorsement as you can get.
So, all this really leaves us with one final important question to think about. This case study proves that you don't have to choose between world-class safety and maximum efficiency anymore. It makes you wonder, doesn't it? How many other facilities out there are just living with their own billion-dollar glitch because their safety system, while it might be compliant, just isn't smart enough for the job?